Now let us take more examples of finite automata. Let us suppose we want to draw finite automata for the following languages. The first language is set of all strings which are starting with symbol A. And all these languages which we will talk here, they will be on summation is equal to A comma B. That means alphabets will be A and B. Okay. Now let us say we have the second language, which is set of all strings ending with A. Okay. Then we will draw finite automata for set of all strings starting and ending starting and ending with, or make it let us change it. So let us have set of all strings. We have starting with A and ending with B. Then we have language L5 is equal to set of all strings starting and ending with A. Then we'll make finite automata for set of all strings starting and ending with different alphabets. Then we'll have set of all strings starting and ending with same alphabet. Okay, now let us see these examples. So for the first example, we have set of all strings starting with A, right? Now for this, what are the strings which will be present in the language? The strings will be A, AA, AB, ABB, ABA, AAA, AAB, AAAA, and so on. That means the initial symbol should always be A in this case. The initial symbol should always be A. Now for this string, how will draw the finite automata? So initially we are at state A. Now we have to identify whether the first symbol is A or not. If the first symbol is A, then after this A, whatever is there, we do not care. We don't care what is after this A. The first symbol is A. But if the first symbol is not A, that means the string is not present, right? So if I am saying if the first symbol is A, then we'll go to the state B and we'll accept the string. And after this A, does not matter what is a combination of A and B, right? Here this transition is saying whatever the combination of A and B will always be at state B. Okay. Now after the state A, initially if we read a symbol B, that means the string is not present. So we'll go to the state C, and whatever the combination of A and B after that will not accept it. Okay. So this finite automata is representing this language. How it is representing this language? Let me just take one example here. Okay, so some of you already understood what I am saying, but if for those who do not understand, for those who the concept is not clear, so let me repeat it again. Let me just go through the complete detail here. So because I want to take every student, even if it is difficult for one to understand within 1 or 2 videos, so I want to address all the students here. So let us say if we have the string BAA and we give the string to this finite automata, then what will happen? If we give the initial this string, after reading the symbol B, we are making a transition from A to C. Then after reading the symbol A, from C to A, C to C, again after reading the symbols A, again from C to C. After reading the complete string, we are again stuck at state C, right? So that means if the initial string is B, then we'll always be stuck at C. But if the initial string is A, let us suppose we have the string which is A, B, A. Now here the initial string is A, initial symbol is A. So if we read the initial symbol A, then from state A, we'll go to the state B. Again, after reading the symbol B, from B, we'll again go to the state B. After reading the symbol A, from B, we'll again go to the state B, and after reading the complete string, we are at state B only, hence this string is accepted. That means if the initial symbol is A, then the string is accepted, but if the initial symbol is B, then we are going to a trap state, which is the state C. Okay. Now let us take the second example here. It is saying set of all strings which are ending with the symbol A. Okay. So what are the strings which will be present here? We will be having a single A. Why? Because this single A is starting with A and ending with A, right? We can have BA, we can have AA because here the last symbol is A. We can have ABA, the last symbol is A. We can have BAA, the last symbol is A. We can have AAAA, the last symbol is A. We can have ABAA, last symbol is A, and so on. We can have any number of strings like this. Fine. That means here the last symbol is A only. All these strings, the last symbol is A. Fine. Now we are saying set of all strings ending with A, right? So we are initial state A. It does not matter whether the string is starting with B or whatever number of B's we are getting does not matter, right? So initially if we get any number of B, we don't care. But assume if we get one single A, that means we will assume the end has already reached. Okay. Now if we get any number of B's after this, so any number of A's after this, then we are assuming that we are again the string is ending with A. Now if we get one more B, then we'll come to the state A. Okay. What is this? I think it is not clear, but let me explain this again. What we are doing here is, if we give any A, or whenever we are getting A, we are going to a final state, but if we get a B, then we will go to the state A. That means if any string is ending with A, then we'll always end with the final state. But if any string is not ending with A, then we'll always end up in a non-final state. Okay. What I mean to say is, assume we have the string which is AAB, or let us take the small string. Okay. So after reading the first A, from A we'll go to the state B. After reading the second A, from B we'll go to the state B. After reading this B, from B we'll go to the state A. After reading the complete string, we are at state A, therefore the string is not accepted, and you can see the string is ending with B. Okay. Now let me take one more example here. If I say we have the string A, B, A, B, A, B, B, assume this is a string. This is a long example, but let us take it. So we have the symbol A. If we read the symbol A, then we'll go from A to B. From the second A, we'll go from B to B. From the third B, we'll go from B to A. fourth A will go from A to B. From the fifth B will go from B to A. From sixth A will go from A to B. Then the next symbol B will go from B to A. Next symbol B will go from A to A. Next symbol, string is already ended, therefore we are at state A, therefore the string is not accepted. That means whenever we have the ending symbol is A, or whenever we are going to see A, will always be a final state, right? So if you see this, then you can see what we have done here is, if we load any of these strings to this tape, then after seeing A, we cannot predict what is the next symbol. We cannot tell you, or it cannot read what is the next symbol which we are getting. We can only see the present symbol and we can make a decision. After seeing the present symbol here, we are always assuming that end has reached. But if after this we have one more symbol, then after reading this symbol, we are assuming that end is not reached. Therefore, we are at this. Or you can say here again, here for this B, we are assuming that end is already reached. Therefore, by reading this B, we are going to non-final state. Again, if we read the symbol A, we are assuming that end has reached. Therefore, after reading the symbol A, we will go from A to B and this string is accepted and so on. Right? Therefore, after reading a symbol, we are always assuming that string is, the end is reached in this case. Okay? Now, let us take next example. The next example is set of all strings starting with A and ending with B. Starting with A and ending with B. Okay? So, what are the strings which will be present here? AB will be present. Why? Because it is starting with A and ending with B. AAB will be present, starting with A and ending with B. ABB is present, starting with A and ending with B. AAAB is present, starting with A and ending with B. ABAB starting with A and ending with B, and so on. Right? That means it does not matter what is the middle symbol. We are always going to look at what is the initial symbol and what is the final symbol. That means initial we should get an A and finally we should get a B. If you are getting a B, that means the string is accepted. If you are not getting a B, that means the string is not accepted. Right? So let us see here, we are at state A. Okay, this is representing string of length 0. Now if we read a single A, that means there is a probability or there is a chance that we can get a B. So if we read a single A, there is a chance that we can get a symbol B. But if initially we are getting a symbol B, that means the string has started with symbol B, which is not present in the language. Therefore, we are going to go to the state C and it will be a trapped state. Okay. So why we are going to this trapped state? We are saying that if the initial symbol is B, then we will always end up in the trapped state because that string is not present here. Okay. Now after this B, if we read any number of A's, then we'll always be at state B because we are assuming that we have to get a B to go to the final state. We should get a B. Okay. So here we are saying if we get a B, then we'll go to a state C, which is a final state, because we are going to the state only because we have seen a A in the beginning and we have seen a B in the ending. After this, if we have any number of B's, does not matter, you can have any number of B's because the string is always ending with B. But if we get an A, then we'll go to this state. Okay, if we get an A, then we'll go to this state. Right? So what do I mean to say here is, assume this is the string is A, B, A, B. Okay, fine. So if we read the first symbol, then after reading the first symbol, we are making a transition from A to B. After reading the second symbol, we are making a transition from B to C, and we are assuming that this B is the last symbol. That is why we are at the final state. After reading the third symbol, we found out that this B was not the last state. Maybe this A is the last symbol. So this B is not the last symbol. Maybe this A is the last symbol. Therefore, the string is not ending with B. So we should go to a state which is not a final state. Right? After reading this B, we found out that this A was not the last symbol, this B is the last symbol. Therefore, after reading this B, we are going from state B to state C, and state C is the final state. Now, after reading the complete string, we found out that we are at a final state, hence this string is accepted. Therefore, the string is starting with A and ending with B. Fine. See, it is not necessary that you will get the same diagram. You can get a different diagram for all these. There can be infinite number of different diagrams for this. There can be infinite number of different diagrams for this. But the issue is, we are not interested in all these different diagrams. We are only interested in the finite automata, which is a minimum finite automata, or we can say minimum state finite automata. We can say it is minimum deterministic finite automata. Okay, that means a finite automata which is containing the minimum number of states. We are only interested in the minimum state finite automata. Okay, so we have seen this example. We have seen this example. We have seen this example. Now let us check the example 5, 6 and 7. Okay. Okay. Now let us see the language L5. I think I have missed the language L4, but let us see the language L5. So language L5 is saying set of all strings starting and ending with the symbol A. That means it is starting and ending with the symbol A only. So what are the strings which will be present here? The strings can be single A, right? So I am not saying double A. It can be single A. Why? Because single A is starting with A and ending with A only. So this will be an exception. Here you cannot get a single A or single B, but here you can get a single A, right? Because the single A is starting with A and ending with A. Fine. We can have AA. We can have ABA. We can have AAA. We can have AAAA. We can have ABAA. We can have ABBA, and so on. That means here starting and ending symbol is A. 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 And again starting and ending symbol is A. In all these cases, we have the starting and ending symbol as A. Fine. For this finite automata, let us say, see, initially we are looking at DFA. In finite automata, we have two types. One is deterministic finite automata. Next one is non-deterministic finite automata. Initially, we are just working on deterministic finite automata. Then we will go to the non-deterministic part. Okay. So here we are at state A. If we read a single A, that means it should be accepted. If we read a single A, that means it should be accepted, right? If after this A, if we get any number of A, that means any number of A's, that means the string is always ending with A. Therefore, if you get any number of A's, will always be at final state. Okay. Now, if we get a B here, if we get a B, we will assume that this may be the end, and we are not at the final state. Therefore, if we see a B, then we will go to state C. Fine. After this C, if we get any number of B's, I will be at this state. If we get a single A again, I will go to the final state. Right. Now, initially, instead of A, if you could have got B, then we will go to the state D, which is a trap state. Okay. Now here you can see what I have done. What I have done, I have started the string with A. I have used this trap state. I have assumed that whenever I am going to get A, I will be at state B only. But if the string is not ending with A, then I will go to the state C. And if the string is ending with A, then I will always end up at state B. Okay. So as you can see this diagram, it is very simple to understand, but for those who do not understand what I have done here, let me make it clear, or let me make it simple here. So there is one more way of making it simple. What we can do is, if you can see this part, only this part, and then you can see this part, only this part. What are these two parts? The first part is only representing starting with A. Second part is only representing ending with a. I have just combined these two parts to make this diagram. I hope you can understand this. Just keep it as a work for you, right? So let me take next example here, because I want you to use some of your brains, right? So let us take the language L6. Set of all strings starting and ending with the different alphabets. Starting and ending with the different alphabets. What are the starting and ending with the different alphabets? Either the string can start with A and but it can have anything in the middle and it can have end with B, or the string can start with B and it can have anything in the middle and it can end with A. Okay, that means the string should start and end with A. Start and ending with the different symbols. So what are the strings which can represent here? It can have AB, it can have AAB, it can have ABB, and so on. It can have BA, it can have BAA, it can have BAA or BBA, and so on. That means starting and ending symbol should be different. That means at least we should get AB or B. Fine. So what we can do here is, it is very simple to understand that this diagram is actually similar to this, but we are going to combine two things here. The first thing will be set of all strings starting with A and ending with B, and second thing will be set of all strings starting with B and ending with A. We are going to combine these two things. How we are going to combine? So let us say the first is set of all strings starting with A and ending with B. Starting with A and ending with B. So what is the diagram for starting with A and ending with B? Starting with A is initial state, single starting with A, okay, and ending with B, right? So this is starting with A and ending with B, and this is starting with B starting with B and ending with A. Fine. So have I done any mistakes here? It is starting with A, ending with B. It is starting with B and ending with A. Fine. And here we have to take, it is starting and ending with different symbols, right? So it is starting and ending with different symbols. So whenever we are going to get this, then what we are going to do is, we are going to combine these two diagrams to make a single diagram where we are going to combine the initial states. We are going to combine the initial states. So how we can combine the initial states? Just see here. We have to combine these two diagrams and make it one diagram. Fine. So how can we make it one diagram? If we are at state A, this is, draw the one diagram similar. Fine. And then here you can see B and B. Combine these two transitions. Okay. As you can see, we have just combined the initial states. We have just combined these initial states. Here on B we had a trap transition, or here on A we had a trap transition. We have just removed these trap transitions from here, and then we have combined these two states and we made one single diagram here. Okay. Now in this diagram you can see we have one single initial state, but we have two different final states. That means it is not necessary that you will always be having one single final state. You can have more than one final state. We have already seen this in the previous diagrams again, right? So we have done this language L6. So it is very simple to understand. take any example, try to read the string. If you face any difficulty, let me know. Okay, then I will make one more video for this. So now next language is L7. So language L7 is set of all strings starting and ending with the same alphabet. Starting and ending with the same alphabet. Fine. So this was starting and ending with A. We have to make something which is starting and ending with B, and then we have to combine these two diagrams. That means if the string is starting with A, then it should end with A. If the string is starting with B, then it should end with B. Let me clear this up and let me make this diagram again. Okay. Now this diagram, it was starting with A and ending with A. Now let me make one more diagram for starting with B and ending with B. So what is starting with B and ending with B? So starting with B, we'll go to state B. This can be A. Okay, I've done fine. This should be B, not A. This is A, and this is A. This is B. This is A. Fine. So this is for starting with A, ending with A. This is for starting with B and ending with B. Okay. Now what we can do is, here we have starting with A and ending with A. Therefore we can just combine the initial states. So after combining the initial state, what we are going to get here is, we have a state A. In one part I am just going to draw this, in second part I am going to draw this. So if we get a A, we go to the state P, single A, B, C, B and A. In the second part I am going to draw this. So this will be, if we get a B, then we go to state D. If we get a, we go to state E. Fine. We have just combined these two states. Okay. So this is starting with A, ending with B, and this is starting with B and ending with A. Okay. Either the string can start with A and either the string can start with B. So this is the diagram. Fine. So let me take more examples. I hope these diagrams are clear to you. So if you face any difficulty, just try to take some examples and take we'll take more examples here. I think by the end it will be. Now let us say we have alphabet is equal to summation is equal to A comma B. We are working on the alphabets A comma B. Okay. Now here what we are doing is, we have string W such that length of W mod 2 should be congruent to 0 mod 2. We have already seen this example. Next example is W such that length of W mod 3 should be congruent to 0 mod 3. Then we have L3 is equal to W such that length of W mod 3 should be congruent to 1 mod 3. Then we have language L4 is equal to W such that length of W mod 2 should be congruent to, or better ways we can take like this, number of A in W mod 2 should be congruent to 0 mod 2. We can have language L5 is W such that number of B in W mod 2 should be congruent to 1 mod 2. We can have L6 as W such that number of A in W mod 2 should be congruent to 0 mod 2. And number of B in W mod 2 again should be congruent to 0 mod 2. Then we will see the example. Language L7 is W such that number of A in W mod 2 should be congruent to 0 mod 2, or make it 1 mod 2, and number of B in W mod 2 should be congruent to 0 mod 2. Okay, then we'll see more examples here. So initially let us start with the language L1. Okay. Now for the language L1, we have W such that length of W mod 2 should be congruent to 0 mod 2, which we have already seen. What are the strings here? The strings will be strings of length 0, strings of length 2, strings of length 4, strings of length 6, and so on. What this language is representing? It is representing even length strings, right? You have already seen this example in the first or second videos. Okay. So we have already seen this example and we have already drawn DFAs for this. So let me just draw this again quickly because I think we have already seen this. So it is initial state is A, which is the final state. If we see A or B, we'll go to the state B. Again, if we see A or B, we'll go to the state B. Okay, we have already seen this. This is the length of the string should be even. Fine. Now let us see the second diagram. This was very simple. We have already seen this multiple times, so there is no need of repeating the same thing again. So here length of W mod 3 should be congruent to 0 mod 3. Length of W mod 3 should be congruent to 0 mod 3. That means whatever the length of the string is, if we divide the length by 3, then the remainder should be equivalent to 0 mod 3. That means the remainder should be equivalent to 0. So what are the lengths which will be present here? The length which will be present will be 0, length 3 will be there, length 6 will be there, length 9 will be there, and so on. 0, 3, 6, 9 and so on. Fine. So for this L2, so what are the strings which can be present? Strings can be of length 0, length 3, length 6, length 9 and so on. So we have to have 3 states. Okay, why we are going to have 3 states? Because here it is showing 0. It is saying if we do a modulus, that means if we divide any number by 3, then the remainder will always be 0, the remainder can be 1, or the remainder can be 2. We can only have 3 remainders, right? What do I mean to say is, if you take any random number, let us suppose the random number is 7. If you do 7 mod 3, then the remainder will always be 1. If we do 8 mod 3, then the remainder will always be 2. Right? If we do 9 mod 3, then the remainder will always be 0. If we do 6 mod 3, then the remainder will always be 0. If we do 5 mod 3, then the remainder will always be 2. Right? Again, if we do 10 mod 3, then the remainder will always be 1. That means after this interval, it is going to repeat itself. After interval of 3, that means remainder can always be 0, remainder can be 1, remainder can be 2, remainder will never be 3 in this case, remainder will never be 4 in this case, right? So we are going to need 3 states here. One state will be representing a remainder 0, one state will be representing a remainder 1, and one state will be representing a remainder 2. Okay, so what are the states here? So we have a state, this state is representing a remainder 0. Let me just say this state as Z. This state is representing the remainder 1. Let us say this state is O, and this state is representing a remainder 2. Let us say this state is as T. So this is going to confuse you, so make it 1 now, so O N E, so make it N. Okay, So we have this state is representing 0, this state is representing 1, and this state is representing 2. Okay, and we want to say if we divide the length of the string by 3, then the remainder should be congruent to 0 mod 3. Remainder should always be 0. That means if we want a remainder 0, then we have to make this state as a final state. This state will be final state. Fine. Now, if we get single A or B, then the string length will be 1. So remainder will always be 1. If we get a single A or B, then the string length will be 2. The remainder will always be 2. If we again going to get single A or B, then the string length will be 3 and the remainder will be 3 and so on. Okay. So let me introduce one more thing here, which will be called as state table or state transition table. So what is the state transition table here? We have to identify what are the symbols. Symbols are A and B, input symbols, and we have to tell what are the states here. States will be Z, N and T. Here the initial state is Z. Initial state is shown like this, and whatever the final state is out of 3, it will be shown like this with a star. Okay. Now if we are at state Z, if we see a symbol A, then we'll go to state N. From Z, if we see a symbol B, then we'll go to N. From N, if we see a symbol A, we'll go to state T. From N, if we see a symbol B, we'll go to state T. From T, if we see a symbol A, then we'll go to state Z. From T, if we see a symbol B, then we'll go to state Z. This is called as state transition table. State transition table is saying if we are at any particular state, if we see a symbol, then to what state we'll make a transition. That is the state transition table. Okay. Now in this state transition table, you can see we have 3 states. Every state is representing one remainder, and because we need a remainder 0, therefore we made the state as 0. Right? And why we go to the states this? See, what do I mean to say? Let us suppose we have the string here A, B, B. Okay. Now what is the length of the string? Length of the string will be 1, 2, 3, 4, 5, 6 and 7. The length of the string is 7. Now for this string, if we read a single A, then from Z we will make a transition from Z to N. After reading the second A, we will make a transition from N to T. After reading the third symbol, we will make a transition from T to Z. After reading the fourth symbol, we will make a transition from Z to N. After reading the fifth symbol, we will make a transition from N to T. After reading the sixth symbol, we will make a transition from T to Z. After reading the seventh symbol, we will make a transition from Z to N. Right? And then after reading the complete string, we are at state N. Right? And this state N is not a final state, therefore the string is not accepted. As you can see, the length of the string was 7. If the length of the string is either 0, then we will be at this state. If the length of the string is 3, we will be at this state. If the length of the string is 6, we will be at this state. Okay. So this was a very simple question. Fine. Now the next question is related to the previous question. In the previous question, it was 0 mod 3. In the next question, it was 1 mod 3. That means if we divide the length of the string by 3, then the remainder should be congruent to 1 mod 3. That means the remainder should be equivalent to 1 only. The remainder will be 1. So if you want a 1 as a remainder, then what will be the final state in that case? Here it is representing remainder 0, it is representing remainder 1. So what we have to do is, don't make it a final state. In that case, make it a final state. Therefore, this will be the final state. Now, this question is representing this. This diagram is representing this question where the remainder is 0. Here the remainder was 0, but here the remainder was 1. That means it is showing the state with 1 as the remainder. Okay. Fine. So now let us take the next questions here. Now let us work on the language L4. So what is this language L4? Language L4 is saying in the string W, whatever the number of A's are, if we divide the number of A's with 2, then the remainder should be equal to 0 mod 2. Okay. Then what are the strings which will be present in this case? The strings will be, it can have 0 A's, it can have 1 A's, it can have 2 A's, right? So it cannot have 1 A's. So what are the things here? We have number of A. If we number of A in the string W, if we divide the number of A's by 2, then it should be congruent to 0 mod 2, right? So if we divide the number of A's by 2, then it should be congruent to 0 mod 2. So that means we have 0 A's, we have 2 A's, we have 4 A's, we have 6 A's, and so on. So what are the strings which will be present in this case? So strings will be B, we can have single B, we can have epsilon, because in case of epsilon we have 0 A's and 0 B's. We can have double B, we can have BBB, we can have 4 times B, because here in all these cases we have 0 A's. We can have 2 A's, so A will be AAB, we can have double A, we can have ABA, we can have ABBA, and so on. We can have 4 A's, so number of A's will be AAAA, AABAA, and so on, right? That means we can have 0 A's, 2 A's, 4 A's, 6 A's, and so on, right? So in this case what we are going to do is, this is the initial state. So in this initial state the number of A's are 0, right? So we'll have 0 A's. Okay. Now if we get a single A, then the number of A's are 1, number of A's are odd, so we'll go to the state B, right? Now it does not matter what are the number of B's are, because we are not going to count the number of B's in this case, we are only going to count what are the number of A's. Fine. Now again we are going to get A, then we'll go to the state A and this string is accepted, right? So it was a very simple example where if we get the even number of A's, then we'll always end up at the state A, but if we get any number of B's, it does not matter because we are not counting the number of B's in this case. Fine. So we have done this example. Now let us see the example number 6 and 7 in the next video. Fine.